Kriti Srivastava and we will be discussing Quicksort in detail. Okay, Quicksort is the most practically used sorting algorithm, and because of some various features that we'll be discussing in this video. What happens is that Quicksort uses meaningful division, while if we take the example of merge sort does blind division and just divides the list into two parts, then into two parts, and so on until we get a single element. And since we know that a single element is already sorted, then after that it combines back and combines them, the smaller element, that is single elements, then after that merging and merging till we get the sorted array. That occurs in the case of merge sort, and which is a blind and meaningless division. Let's take an example of we can say India Pakistan border troubles. What happens is that if we could have asked at the time of partition, India Pakistan partition, if we could have asked the neighboring people living there, where do you want to go, India or Pakistan? If we could have asked them before, then there would have been a very different situation, more clearer situation, less troubles would be there than as of now. Okay, so we can relate merge sort with the help of we can relate merge sort like similar to that India Pakistan border situation or partition algorithm. So here what happens, quick sort is smartly takes the decision and performs the meaningful partition, and it performs meaningful partition with the help of partition algorithm, and which is the key algorithm, and which is the hero algorithm we can say, and which is very important. If you know it well, then quick sort is very easy. Okay, then first of all start with the partition algorithm. I will give you a brief by with the help of some integer variables, integer values, set of integer array. Then after that you will be getting the algorithm very nicely. Okay, so let's take an example. Let's take an example like 10, 45, 5, 60 and 75. Okay, suppose we have got an array like this, array of 5 numbers, and let's name this array as A. We have got integer pointers as P as the starting pointer and Q is the ending pointer pointing to the end of the list array. And then what happens is that we are taking like this. Okay, so partition algorithm says select a pivot element. So for the sake of simplicity, we are taking the first element as a pivot element. It's not necessary to take a first element as pivot. You can take it anyone. Okay, so for the simplicity, we are taking the first element as a pivot element. Then I will be another pointer will be pointing to this one. Okay, pivot element. Then what happens is that J will be there will also be a pointer J, and that will point to the I plus 1. Okay, or P plus 1 we can say. Here what happens is that I and J both have different purposes, and that's why they came into picture. Okay, so I takes the smaller people and J takes the greater people. What do I mean by smaller people and greater people? I mean that taking the pivot element at the end of the partition algorithm, what we are getting is the correct position of the pivot element. That is, the elements to the left of the pivot element are less than the pivot element, and elements to the right of the pivot element are greater than that of the pivot elements. That's what means by the correct position of the pivot element. Okay, so this is the initial position of the pivot element, that is the first position, that is what I is pointing. At the end of the partition, I will point to the correct position of the pivot element. Okay, so what happens is that both I and J both want to move. Okay, since I wants the smaller numbers and J wants the greater number than the pivot element, and then they both want to move, but it is unnecessary waste of time. So they both make a deal or compromise that J says I will move. Okay, I only will move, and if I get greater, I will just skip and move further. And but if I get smaller number, I will give it to you, J says to I will give it to you, and in return, but in return you have to give me a greater number. So for greater number, we can say like great I plus 1 will always be greater than a pivot element because J has crossed it. Okay, so I plus 1 will be the greater element, so I will be incremented to I plus 1. Then both I and J will swap their places, and I will get what? Okay, I will get the smaller number. So that happens, and at the end what happens is that we will be swapping I and P. So that happens. That will be more clear with this example. Okay, so let's start this procedure. Okay, J is pointing to 45 and I is pointing to 10. Since 45 is greater than 10, J will move, skip and move. It will not do swapping. And then what happens? Then I will increment J, then I will get 5. Okay, so I'm getting 5 which is less than 10. So J gave a promise to I that it will give lesser number to I. So what happens is that I will be incremented. Okay, so I has incremented here, and both will swap. Okay, both these values will be swapped. So here comes 5 and here comes 45. Okay, okay, now J's work is over. Then J will be incremented. So J comes here. So J is pointing to 60. 60 is greater than 10, so it's okay. Greater people skip and move. Okay, so skip and move. Then J 75. Okay, 75 is also greater than 10, and then you have then done. So it will move further. It is trying to move further, but there will be a restriction. If J is greater than Q, then we will come out of the loop, and the partition algorithm will be finished. And after that, what will happen is that we will swap. Okay, we will swap this I and P. Okay, so I will swap this 5 and 10 goes to here. So here at the last I will give the correct position of the pivot element. So if we write it here like 5, 10, 45, 60 and 75, elements to the left hand side of the pivot element are smaller than 10, and elements to the elements to the right hand side are greater than 10. So this pivot element gets its correct position, that is 2. Okay, 1 2 3 4 5, suppose the positions are labeled as this. So pivot element gets to second position. So this is the logic behind the partition algorithm. In the next lecture we are going to discuss the main partition algorithm. Okay, we will write the partition algorithm. Thank you.